Thank you, RNC sir, for allowing me to host today's lecture. So today we have a wonderful lecture by Dr. Debesh Choudhury. I am Rajiv Chakraborty, an alumnus of this department. I joined this department in 1992 with specialization in optics and optoelectronics. Presently, I am the professor of the Department of Applied Optics and Photonics. So you may be aware that this department is actually the faction, the optics and optoelectronics section of the Department of Applied Physics. So my research area is photonic integrated circuits as well as nanophotonic devices. Anyway, let me, because this is a lecture by Dr. Debesh Choudhury, so it is customary for us to introduce the speaker. So I'll be doing that before Dr. Debesh starts his lecture. So Dr. Debesh Choudhury is presently an advisory board member of Mnemonics Identity Solutions Limited, UK. He is also a principal researcher of InfoSense Research and Engineering since October 2017. Between 2018 and October 2019, he was also the principal researcher scientist at DAS Lab Asia. Prior to that, from 2007 to 2017, he was a professor of ECE department, first at GIS College of Engineering, then at NITMAS and Adams University. After completing his PhD, he joined IRD Dehradun, which is a DRDO lab, and he joined there as a scientist in September 1996 and worked there up to April 2007. Dr. Debesh has completed his PhD from the physics department of IIT Bombay, where he worked in the field of applied optics. He is an alumnus of the Department of Applied Physics and has done his MSc Tech degree in 1989 in the field of optics and optoelectronics. During his long academic and industrial career, he visited different universities worldwide, either as a postdoctoral researcher or as an invited speaker. He collaborated with different distinguished scientists that includes Professor Caulfield of USA and Professor Takeda of Japan. People working in the field of optics are already aware of the immense contribution of these collaborators in this field. Dr. Choudhury has several research publications in top-notch journals as well as international conferences. There are endless other academic accomplishments of Dr. Choudhury, and we have mentioned only some of them. Lastly, I would like to say that, and you will be happy to know that also, that he is a very good tabla player and has performed in Doordarshan and Calcutta. And presently, he is working in the multidisciplinary field of optics, computer science, as well as in the field of computer science recently. Okay, with these few words, I will request Dr. Choudhury to start his lecture. So I think he will be taking around 30 minutes. And after that, maybe we can have some questions. So I will request Dr. Choudhury to start the proceedings. Dr. Choudhury.
Yes. Thank you, Rajiv, very much for the introduction. So the title, as you know, it is already written and the presentation is in now presentation mode, full screen. So the title is Biometrics Rush, Inconvenient Truths of Biometrics Technology. So it is actually a application of pattern recognition and biometric authentication. You can say, as I have written here underneath, that it is a story of unreliable pattern matching.
Can you make it full screen?
Full screen. It is full screen, not full screen?
No, not yet.
Why? It is full screen. I've made it
Yeah. Now it's full screen.
full screen. Yes. So and this is the overview outline of the lecture presentations. So we'll discuss something about pattern recognition and how biometrics also comes from pattern recognition applications, and a brief about my research in the field of biometrics. It is 3D object recognition and then applying to three-dimensional face recognition. And I will point out the problems associated with biometrics. And that is a question that still that all the banks and the financial institutions like credit cards, everybody, they are using still the default authentication mechanism in text password. So that is the question why it is. So and also we'll try to find out if there is any alternative solution which also improves, say, the text password as well as the problem about in biometrics. And as I mentioned, the title is Biometrics Rush. So some conclusive points at the end, and then you can ask questions. So pattern recognition, it is a well-known field. It is an application of many work, including computation and capturing the objects and everything. So recognizing the objects and the surroundings environment is a trivial task for human beings, as we know that we recognize each other in the family, around the in the office and everywhere. So it doesn't take any effort. We effortlessly we just recognize. But pattern and object recognition is a complex task for machines and computers. Pattern recognition involves developing complex algorithms and considerable computational tasks. Schematically, it is like this, say object or patterns which are either captured or sensed by some camera or sensors. Then it is pre-processed before it is put into the algorithmic processing inside the computing machine, and then it gives some inferences from where we can say that it is recognized or it is rejected. Pattern recognition can assist solving various inference problems associated with bioinformatics, document classification, image analysis, data mining, industrial automation, biometrics recognition and authentication, the subject we will also discuss very detailed, and remote sensing, handwritten text analysis, medical diagnostics, speech recognition, GIS, and many more. Pattern recognition depends on mainly on the amount of data we have to process and the technology involved, and also finally the designer and the user who uses it, like say banks and other organizations. Pattern recognition uses various yes.
No, you can carry on.
Yes. Some microphone noises are coming. Yes. So pattern recognition uses statistical, structural, template matching, cross correlation, neural networks, and many various techniques. So coming to optical character recognition, which is very popular and it is very regularly used nowadays. So we learned optical character recognition is in a course on holography in the first year of MSc Tech in applied optics, applied physics, optics and applied physics in the department. We are alumni of, and this is a schematic diagram which shows three figures. The block diagram of an optical character recognition system. It is in the first one, left hand A, and B is optical realization of optical character recognition. We call it matched filtering, and C are the results. So in B, we can see it is illuminated by an collimated beam. The input is the impulse, the filter function SXY. No, sorry, the impulse response which we want to carry out under the filter function S star FX FY. FX FY are the spatial frequencies, and L3 is another lens which does another. I mean, the first lens makes it collimated beam, and the second one does one Fourier transform, and the third lens L3 does another Fourier transform, means inverse Fourier transform. So we get the in the frequency plane the result. So the results are shown in C. The C1 is the input function SXY, and C2 are the result. So we can see that we are trying to match with the input. Sorry, the input is QWP. Um, the third one, which is actually C2. So QWP are the three alphanumeric characters. We want to match it with P. So the input filter function is actually C1, which is P and P star. So when it is convolved using that lens geometry, the Fourier transform, optical Fourier transformation, we get the output C2. In C2, we can see that at the location of P, we get a sharp peak, means a dot, and it also specifies the location. So there is a optical character recognition and also localization where it is situated. So this is a picture, everything. It is a reference of Introduction to Fourier Optics, a well-known books by John Goodman. The idea of optical character recognition was clear while we are studying. While we are studying, it is a concept. But when we experimented during our research in PhD research, I understood the principle behind it by recording holograms and reproducing the correlation at the correlation plane. Optical character recognition has applications in automatic, printed, or handwritten document to text conversion, which is regularly done now, also empowered by AI. Biometrics pattern recognition. Biometrics are automated methods of recognizing an individual based on measurable biological, anatomical, and physiological and behavioral characteristics or traits. This includes fingerprints. Biometrics includes fingerprints, facial features, iris patterns, voice, hand geometry, palm vein patterns. Palm vein patterns are not visible, it is underneath. So we have to use some infrared sensor to capture it. And gait, such as walking or typing rhythm, which is technically called keyboard stroke dynamics. Or even the body odor like sweat. A biometric system can operate in two modes. Like one is for verification or authentication, which verifies person's claimed identity via one-to-one comparison. And number two is identification, which is more challenging, which determines an individual's identity through a one-to-many comparison in a database. Suppose this is the situation of verification. So the name and the ID number is there. So pictorially it is shown that somebody is trying to log in using fingerprint or facial biometrics. And the second case, identification, one to many, it shows the scenario. Say the blue colored extreme top list, the person has to be uh, identified from a database of many people. So it can recognize and identify. So let us see how biometrics recognition works. The significant feature, I'm just showing it by some schematic diagram of a face. So face biometrics. The significant features of a face consisting of the nose, eyes, and their locations are utilized as a metric to distinguish between faces of different human objects or subjects. So accuracy of recognition, it greatly depends on the illumination, the skin color, orientation, size, that means scale, rotation, etc. parameters. And the accuracy of recognition is always less than 100% and can be lower, 97%, 95%, or even lower depending on the condition of face image capturing in this case. On the other hand, the text passwords, what we regularly use nowadays, and for banking or other financial, say, credit card also, the text passwords work on the principle of comparing the stored hash. Hash means 25, SHA-1, many are there, many type of hash functions are there, of the text password. So the company server, they keep the hash of the passwords. With that, the input text streams, the passwords when we entered, it is compared by a XOR operation. Text passwords yields either matching if the stored hash matches with that of the input text streams, or rejection if the hash patterns don't match. So my research in pattern recognition. My interest of pattern recognition grew while working in the DRDO lab, mainly in correlation pattern recognition. That example I gave in the beginning, like that matched filtering, it is actually a correlation pattern recognition. How it works? It works like the comparison of the input and the filter function, and then we can get a sharp peak or at the location of the particular object recognized. But those were recognizing 2D patterns and images using Fourier transform, joint transform correlation, or any other correlation function. So correlation operation. But in the real world, the objects are three-dimensional, so it asks for developing 3D object recognition system. So I implemented 3D object recognition by combining correlation pattern recognition in Professor Takeda's well-tested Fourier transform probabilistic 3D sensing system. That is a Fourier transform probabilistic system which actually is regularly used by industries for shape measurement. So that information I used and applied it in conjunction with correlation pattern recognition and achieved 3D object recognition. And then I applied the new 3D object recognition technique to three-dimensional human face recognition and obtained satisfactory results. These are actually the technique which that iPhone of Apple started working. They have given a 3D Face ID feature from 2016 onwards. I experimented the system with pose and orientation variation of many human faces. So how 3D shape sensing and object recognition of my technique work. So very briefly, I show some schematic diagrams and some the objects, actual photographs, and also the process. This is a work which is published in Optics Letters in 2002. The title is Frequency Multiplexed Profilometric Face Coding for Three-Dimensional Object Recognition without 2π Phase Ambiguity. The top figure, figure 1, it shows the schematics of the setup. It is showing a cross-sectional view, object 1 of some height, say it is a wooden block. Another object 2, which is a similar shaped wooden box of different height, which is illuminated by a grating pattern from a projector with an angle, theta. And that pattern are projected on the object, so it gives a distortion in the projected pattern as per the shape of the object compared to the plane where they are placed. And this pattern projected image is captured by a CCT camera from the top, 90 degree from the top. So the figure A is a photograph of the two object blocks of same shape but different height. So this is the target shown in B. The smaller one is the target. We have to recognize it from the two. And C shows the pattern projected top view, which is captured by the CCT camera. And figure D shows an enlarged view to show you how the grating patterns are actually seen by the camera. So this is a plane where the objects are kept, and you can see for the object it is slightly different positions. So because of the angle theta, we can get it. Figure E and F are the corresponding phase maps, unwrapped phase maps, which are computed using Professor Takeda's Fourier transform technique. And these two phase maps, when are cross-correlated, we can yield a correlation peak shown in figure G. And figure H shows an erroneous result using a very simple pattern projection. Like here we have used a multiplex pattern, like two patterns. And by the two patterns, we can distinguish between the similar shaped object of different height. That is why we have written 2 pi phase ambiguity. Because in the projection, it can happen that getting pattern on the floor, and also the pattern on the objects can coincide, but they are having different amount of phase shift. But with the 2 pi phase ambiguity, we can actually distinguish between the two objects of the similar shape. I also did some different shape recognition, but that I have not presented here. So this technique I have applied with 3D face, because three-dimensional face is, I mean, our human face is also a three-dimensional object. So we can do the same technique here. So here are the schematics. This is a work which I published in the Journal of Optics in 2009, three-dimensional human face recognition. This is actually the first issue of the Journal of Optics, co-published by Optical Society of India and from Springer. So the top figure 1 shows the schematics of the diagram. So we can see a human is standing in front of a wall, and a projector with some angle, it is projecting some fringe pattern, grating pattern, and the camera from orthography, it takes the pattern projected images on the face, and it is a computer connected which will compute the captured data and yield the recognition. So figure A and B are pattern projected to one person's face with different orientation, and figure C and D are also from the same thing for another person. So when we compute the phase map by the technique of Fourier transform technique of Professor Takeda, then we get these EFGH are the corresponding phase map of the pattern projected images captured, shown in A, B, C, D. And when they are cross correlated, say for the same person, we get a high peak, which is shown in figure I, and in J, we don't get any high peak, it is a noise, which are actually result that the two persons are not same. So I have done this three-dimensional face recognition and many other applications for quite a long time, about say 15 years. I presented papers in China. I presented this also in different application of encryption and privacy protection in USA. But after carrying out deep research, I found I was not satisfied. Actually, I found some problems associated with biometrics. What is that? I was not satisfied with biometrics recognition technology. There were various reasons. Number one, biometrics recognition is probabilistic and not deterministic, like text passwords and pins. Like say, I explained that the text passwords are compared with using the hash, stored hash with the input hash. Here it is not like that. It is like salient features of nose, eyes, many other things, or say the ridge and other things of fingerprint, and then it is compared. And that comparison is very rough. So it is having a recognition, say 95%, 96%, never 100%. So this does not produce any deterministic yes/no result like the password hash comparison. So biometrics cannot yield deterministic yes/no result. This is a very important point if you want to apply it for say banking or financial application. Biometrics is spoofable, and spoofing technology is progressing at an alarming rate. If you have read the newspapers during the last, say, from 2017 onwards, you can find that that our digital identity of India, that Aadhaar, they had a biometrics also. They had some Aadhaar-enabled payment system connected with the banks, which enables people to withdraw money cash using fingerprint. So since fingerprint spoofs are very easy to make, so still now continuing, people's money are looted using fingerprint spoofs, and it is increasing. If you go to a bank, if you stay there for say half an hour or 1 hour, you will find in the window people are complaining that my bank is looted, my account is looted. So the bank has no solution. They just say that you go to the police and file a complaint with the cyber section, cyber police. Biometrics can be copied, collected from public places and social media. This is another important problem, that we have high resolution images nowadays in social media. Even from that high resolution images, we can collect their IDs data, or say in a public place somebody is drinking by touching a glass. So while touching a glass, your fingerprint is I mean, generated there, which can be also collected. So these are the problems, that it can be copied from the public places. So, and another very problem people face, that biometrics data once stolen, say hacked or lost, are lost forever, because biometrics cannot be reset like text passwords and pins. You can remember there were notices, newses, you can see that complete Aadhaar database was hacked. And in the dark market, it requires only say rupees 500 to get the complete database. Nothing could be done actually. That company, the corporation, our government organization, they also are silent, and people are also silent. Even that news reporter who demonstrated that, the government sued her. She is facing legal suit, instead of actually rewarding her, that she pointed out that it is bad, it is having some problems. Biometrics has finite false acceptance and false rejection rate. That means, say, when you are trying to log into your account using your biometrics, you may not be permitted. It will be like false rejection. You are the authentic person, but you cannot enter. Or it can also, it can happen that it can permit some other persons which are false acceptance. So this cannot be accepted for financial or banking transactions. So biometrics is having credential stuffing issues, which means using the same password or authentication token for many accounts. This is one thing everybody knows, that you don't keep your password same for many accounts. But here in biometrics, you have to do it, because biometrics is only our biometrics. So biometrics, the points I just point out here separately. Biometrics proofs are easy to make, and it is progressed at an alarming rate. Criminals are looting people's bank account using fingerprint spoofs and other enabled payment system. Last year, the police commissioner of Kolkata asked people through the news channels that please disable biometrics in your Aadhaar to stop such looting. And in this context, I will just point out another thing, that there is a University College of Chemical Technology, UTCT in Bombay. So they had a fingerprint system to check attendance of the students. So what was found? It is in 2017. The teacher found that less than 50% attendance physically, but the record is more than 90% attendance. How that is happening? The students generated some fingerprint spoofs using, because they are chemical subjects they study. So they have found that the overhead transparency sheets we used to use for our presentation earlier days, that can be used to generate fingerprint spoofs. So by that, they can actually say one student carrying say 10 or 12 students finger thumb impression, and they are getting the authentication done. So same biometrics for all online accounts, it is a very big problem. So once biometrics is stolen, means all accounts are in the hands of the criminals. And another question which also you should ask, why the banking and the financial systems worldwide, they are still using text passwords and pins as the default mechanism? Why are the banks and financial platforms keeping text password security as the default authentication factor? Why don't banks make biometrics as the default authentication factor? Because the security professionals very well understand that biometrics is unreliable and can lower security. The banking sector understands that text passwords are more secure than biometrics. That is why they are just continuing with the default as text passwords. Alternative solution could be there. It can be say graphical authentication security using image as passwords. This I was introduced to by one Hitoshi Kokumai. I have seen some research papers, but Hitoshi Kokumai is from Japan. In 2019, I connected with Hitoshi Kokumai on LinkedIn. He is the founder of Mnemonic Security Incorporated Japan and pioneered the expanded password system (EPS) that can accept both text and images as passwords. So they had their system sold to different, purchasing departments like online purchasing platforms, as well as the Japan land defense, that's the defense department. So I quit biometrics and worked with Hitoshi Kokumai on graphical passwords and expanded password system. In 2021, Hitoshi Kokumai founded the global company Mnemonic Identity Solutions Limited in the UK and initiated conversion of the Japanese EPS software into English. I participated in that work, and I have been now in the advisory board of Mnemonic Identity Solutions. So to give you just an example how it works, that expanded password system, this is an image matrix, say having an image matrix of say 1 2 3 4 5 6 1 2 3 4 5, so 30 images. So you can select say 1 2 or 3 images out of these, which are your particular selected images for your password, and then if you enter it will create a very complex hash out of that images, and that can be used as your passwords. So this is the basic mechanism. If you are interested, you can come to that website and you can check that web solution free of cost. And now we are partnering with some quantum resistant cryptographic company of Switzerland, and we are having a collaboration. So this is actually the title, Biometrics Rush. So biometrics is having a very limited use case. Biometrics has a very limited application such as access entry control, with human staff to support in case of problems, like say while we are entering an office. So security staffs are there. If there is any problem, say mismatch or something, so people can help. I have seen in banks, say very old persons, they are not able to withdraw their pension because their fingerprint is not there. Means it is died. That reach and other things are not there. But the bank staffs, unfortunately, sadly, they are not actually helping them. They could have just asked them, requested that you apply and disable biometrics and use the that check, physical check to withdraw money. Instead, they are saying that you come some other time, your finger is defective or something like that. So government regulators utilize biometrics to track and control the citizens in a crowd. This they can do because they want it, and there is no accuracy required here. Police departments use biometrics as an additional information for identifying criminals. And for your information, this is not actually accepted by the legal systems. It is an additional information. This is not the final, like biometrics match means it is a criminal. No, because they also know that it is not foolproof. But in all these use cases, accuracy of biometrics recognition does not matter. So, in my opinion, it is a rush with biometrics. The tech community is rushing with biometrics deployment for authentication tasks. Reason? Very simple. The big tech corporations, companies, they have invested a huge amount of money in biometrics. So they cannot come out. That is why they are pushing biometrics in every platform. It is true, biometrics is convenient. You can just put your face in front of the camera or put your finger. But because of that problems, it can lower security. Convenience and security ability bear an uncertainty relationship. This I noticed and highlighted. And if convenience improves, security ability lowers. This is the truth. We can show this graphically. Say the x-axis is the um convenience, and the y-axis is the security ability. So when say you have a point high convenience, that means you have a lower security, and a point which is having a high security ability but a very low convenience. So that is actually the truth. So please think over it. So that is all. And if you have any questions, please ask. And please visit my LinkedIn profile, connect with me at LinkedIn, and explore my work. We can cooperate and collaborate on subjects of common interest. So this is the end. Thank you very much. If you have any questions or any suggestions, you can please ask.
Thank you, Debesh sir, for this wonderful talk. So now the house is open for questions. So if anyone have any question, they can ask.
দেবেশদা,
ইয়েস,
আমি কনিক বলছি।
হ্যাঁ বলো।
বলছি যে একটা প্রশ্ন খুব সহজভাবেই মনে আসছে যে যখনই আমরা বায়োমেট্রিক করি বা পাসওয়ার্ড প্রোটেকশন যাই করি না কেন, অ্যাকচুয়ালি দুটোর ক্ষেত্রেই মেইন প্যাটার্নটা একটা কোনো সার্ভারে স্টোর হয়ে আছে। আর যে জায়গা থেকে ওই প্যাটার্নটাকে জেনারেট করা হচ্ছে সেটা একটা কোনো কমিউনিকেশন চ্যানেলের মাধ্যমে মেন সার্ভারে কানেক্টেড হচ্ছে। তার মানে আমরা যদি প্যাটার্নটাকে যেভাবেই জেনারেটেড হোক না কেন, ওই সিকিউরিটি যে কোয়েশ্চেন্সটা কমিউনিকেশন চ্যানেলের ওপরেও একটা ডিপেন্ডেন্স আছে। তো সেই জায়গাটা কি হতে পারে, মানে সেই জায়গাটাকে আরো সিকিউর করার জন্য কি করা যেতে পারে?
না, সেটা তো চেষ্টা হচ্ছে, দ্যাট ইজ ম্যান ইন দ্য আই মিন path attack. Means generally it is very difficult and it is not, I mean all the cyber passwords things, it did not actually happen in the man in the middle, like while in the communication channel. It is actually from the server, they are collecting the unhashed or hashed data, because the security of the server of that company or particular that digital identity company is not good, like say other system. All the other database, say the names and the corresponding biometrics, and that is actually a bad thing that it was not encrypted at that time, or other. So they have the raw biometrics data as well as name and connecting things, everything. So man in the middle attack is very difficult, and it is I mean, you can say that all the cyber breach are not actually done there, though there are researches. I have not done any review on that, as you are pointed out. So it is a of course a point I can also look into and find out, and maybe in some other occasion I will present that what is the situation in man in the middle attack.
Okay,
Good
thank
point.
you, thank you.
Good point.
Thank you, colleague. Any other question?
Okay, I have some question. One question.
Yes.
Thanks, Mr. Debesh Choudhury, for exploration of use of biometrics.
Yes.
But my one question is that you have said that you have discarded the biometrics.
Yes.
Biometrics.
Yes.
But you have said some merits and demerits. But my question is that there are so many demerits, but in spite of that, banking and financial institution and so many institutions have already used the biometrics as the main password actually. And why it is happening in the old world?
I have pointed out they have to actually not accept it. They are keeping text password still now. All the banks, credit cards, financial systems, they are still continuing with text passwords as the default, and biometrics is just kept as a additional feature, like an attractive feature. Banks, financial systems throughout the world, as of today, they are using text passwords as the default mechanism. Biometrics is just they are testing it as another option. People are attracted. So people are attracted, and some people are losing money. In India, using fingerprint spoofs from 2017 onwards, huge number of people lost their money. I just went to State Bank of India, our HB Town branch. I was there for more than about half an hour. At least 4 persons came and complained that স্যার আমার তো টাকা চলে গেছে 30,000, মানে 30,000 টাকা অবধি ম্যাক্সিমাম বোধহয় উইথড্র করতে পারে. সো ইট ইজ ডান ইউজিং ফিঙ্গারপ্রিন্ট প্রুফড অ্যান্ড দ্যাট আধার kiosk keys. It is a cash withdrawal, and there is no, it is an authentic way, and there is no way they can catch. They can find out which kiosk key it is withdrawn, but the criminals are expert. They just hide the camera, so you cannot have any that way to catch them. So still now text are still the default things, and why they are actually putting that as a main thing. The reason is the tech community is rushing with biometrics deployment for authentication trust, because the big tech companies have invested huge amount of money in biometrics. So they wanted that their money, because they have invested, they want that it should be used, and they are lying. They are saying that biometrics is convenient. Very true, but biometrics lower security. That never they say. They said biometrics is convenient, attractive, and even some people they say that biometrics improve security. That is 100% lie.
Okay, you are correct. Then it is the responsibility of the bank to discourage the use of biometrics of the customers. Actually, then it is the responsibility. Well,
See,
you
bank
have said already that tech companies have invested a huge amount of biometrics. Then bank authority cannot do anything.
yes, cannot
Okay.
do anything. They are
Okay.
just the users, so they have to accept what the like big
Bank
tech.
provides.
No, not bank provides. I'm saying bank is also a poor organization. They cannot have any say because it is the big tech suggestions. Like say in 2003, Bill Gates said kill passwords. So that way it started. So kill passwords, why? Why to kill password? Because it is still the best authentication secure method.
Okay. Thank you.
Yes.
Any other question? So if there is no other question, I have a question.
Yes.
So how authentic is the text password system? Because we are seeing that previously we are using 4 words as a password. Now we are going to 6 and 8 and sometimes in 11 and 12 also text as used as a password.
Yes.
So they are increasing the number of words that they are using. So
Yes.
that means there is also some limitation in the text things. So that's why I'm asking how authentic is this text and password, text type of things as a password.
No, I mentioned where probably this slide or second slide. Yes. The text password work on the principle of comparing the stored hash. Hash is actually, say, if you have a image or a text, if you run a hash function, it is a one-way operation. It will create a very big, like it will look like a garbage pattern, text, but it is actually password. That hash pattern is stored in the server, and when we again enter our password, it will also create the corresponding hash and it will compare with XOR operation. So that XOR, you can check it. You can say use some password, and so the largest the number in the text string, so more there is a chance that people cannot actually guess. And there are programs also people try to say small passwords, say 4 5 6 passwords. You can see there are some hash lists also. Say one company, they had a problem. They had put their admin password as cyber1234. So that type of thing are very easy to find the hash function stored. Like these hashes are common, but if we make our passwords complex and very big, then it is not easy to guess that and create your password. And our alternative solution, as we mentioned in this slide, here say you are using some images to create that hash, and you can also check in your computer, say take an image or any file, any PDF file. Say if you take a hash of that, it will create a very large text streams containing control characters and many other things, ASCII characters, and that will corresponding to that hash. So that means you can generate a complex password using an image. So this is because it is a XOR operation. So one letter, say the hash is 125 characters. So one letter, if it is different, how it can be different. Your input text streams are different. Your input image are different. So that way it is strong. It is strong means if you compare it by XOR operation, it is fast also. And if it does not match with one character, which is actually the hash, then it will not give you entry.
Okay, understood. So is there any other question?
রাজীব দা, আমি আরেকটা জিনিস
বলো।
জিজ্ঞাসা করতে পারি?
বলো।
Yes, sure.
হ্যাঁ, না, the second question
না
is
কোয়েশ্চেনটা আমিও জিজ্ঞেস করতাম, কিন্তু আমি জানি না, অনেকটা টাইম হয়ে গেছে তো।
না, ওর জন্য কিছু
সেইজন্য
অসুবিধা নেই, টাইমের জন্যই বলো।
it's okay. No,
So you can carry on.
yeah, another layer of security nowadays is added, which is essentially, an OTP together with the standard hash or image or text based passwords,
Yes.
where there is a temporal aspect to it. That means during this time, within such a
Yes.
1 minute or 15 seconds, something like that, which is instantly generated, and then you have to put the password. So therefore that's an added layer of security, which is like a temporal, and then image or everything is like a special information which is already stored and compared.
Yes.
So
Yes, PIN, that is called PIN, PIN. So it is called two-factor authentication. Say you have your passwords you enter, and then the server of the banking system, they send a SMS at the some number or something, that is called PIN. You enter that PIN, you get entry. And in this context, I can suggest you something which is also very interesting. You can actually store that. Say it is not actually a dynamic two factor, but you can say it is a quasi two factor. Say you can store some 4 5 or something very simple thing in your brain, you can remember, and your text password is very complex, which is stored somewhere. You copy that and insert it, and then add at the end your stored brain one with that. So it will add that, and it will as a quasi two factor, and it will go to the server. Means, say even a criminal have a hold of your computer and collected your that very complex password which you have saved it. They cannot go to login, because that quasi say pin in your head, it can be anything, any word, say optics or I love Calcutta or something, what it is your code. So that is Hitoshi calls it a free solution, like quasi two factor authentication, which will not go to the even say your mobile. Like your mobile SIM also can be swapped nowadays. It is also possible. They can create a duplicate SIM, and
yeah, I
yes.
understand.
So that
No,
means
what my question was, now there are many apps, like
yes,
some payment apps where
yes,
you have the option of looking at your SMS where the OTP has come,
yes.
and directly that password will be inserted in the following, instead of you typing manually the OTP.
That
So
is
in a
actually
sense
yes,
that your
yes,
your company, mobile company, or whatever app platform that is accessing your
yes.
OTP information with with your knowledge, obviously,
Huh.
but it can act as a
Hacker.
hacker,
Input to the cybers, yes, cyber criminals. Yes, this is not actually good. I generally don't do any banking transaction using mobile apps. I do everything on desktop apps, and this automatic utilization of like reading the app will actually take your permission that it will say check all your SMS and other things. So that is not good actually. Yes, you are right. There is a way they can actually, through the banking system, they can collect all.
Okay, thank you so much, thank you.
Thank you.
So if there is no other question, let us thank Dr. Debesh Choudhury once again. We had a wonderful talk. We learned many things from his talk, and hope in future also this alumni association will come out with other lectures which are very interesting to the community, applied physics community.
Okay, thank you very much for the opportunity to our sir, Professor R.N. Chakraborty, for kindly permitting me to make this presentation. And incidentally, Biometrics as Inconvenient Truths of Biometrics Technology is actually a book I'm writing. So this interaction also gives me some inputs. So it will be published, but I did not publish. That is good, because I am getting many points and questions which will make me more qualified to complete this book. So, okay, and please connect with me on LinkedIn and have a interaction. Thank you.